Hi, geometry. Okay, so we're back at it. We have one more unit to talk about before we look at our finals and get ready for summer break. I know everybody's super ready for that. And we're going to be talking about lines today. We're going to be talking about lines and segments that intersect circles. So this is 10.1. And we have just a couple of sections on circles. But first, we're going to talk about some vocabulary with circles. Notice that I want you to know, not notice, I want you to know that these, the reason that we're just doing a couple of sections is we wanted to pick out those things that are going to be on your SAT test. So that's why we're doing one last unit before we start studying for our finals to send you off for summer. So let's do some vocabulary here. You know a few of these things already, especially from just doing our unit on 3D figures, but let's just review some of our segment lines and segments of circles. So notice that the segment or the chord that goes all the way across our center of our circle is called our diameter. You already know that one. And our radius is always half our diameter, and it goes from the center to the outer edge of the circle. There are a couple of other things that I want to show you. One is a chord. So here's a chord in green. It's a segment that runs across the circle from one end to the circle of another to the other. Notice that a diameter is a chord, but the diameter is a very specific chord in that it goes through the center of the circle. We have another one called a secant. And notice that a secant is a line that goes through the circle. And we have one more here. I'm going to try to draw it really nicely. And it's called a tangent. This is called a tangent. A tangent only touches the circle at one point, and it creates a right angle with the radius. So let's define these things. A chord is a line segment from endpoints. Of a circle. A diameter is a chord that goes through, that passes, how about passes? That passes through the center. And we also know that it is twice the radius, right? All right, a radius is a segment that joins the center of the circle with the outer edge. And then we also have a secant. So here are some lines. Secant, a line that passes through 2 points in the circle. And then we have our last one, which is our tangent, which is a line that passes through 1 point on the circle. And very important here, creates a 90-degree angle with the center. So if you draw a radius or a diameter to a tangent, you're always going to create a 90-degree angle. So there's our vocabulary for our lines and segments. Our test this time is just going to be a vocabulary test. We'll have some problems on there. But here I want to talk about some practice here. So, this is not helping me. All right, a couple of things that I want to talk about that's going to be in your practice for today, or really for tomorrow, is our tangent theorem. Okay, so this tangent theorem states the tangent segments from a common point, external point, are congruent. So let me show you an example of this. If you have a circle, right, and I'm drawing a tangent to this common external point, and this is something that we'll do in class together. Remember, tangents touch the circle only at one point, right? So common external point are congruent. So they're equal to each other, right? So let's try some examples here. So here's one example. And we have a circle C, and I have points S and T for my tangent, and I have an external point, common tangent point here, R. So the length of R to S is 28, and the length of R to T is 3x plus 4. Well, because of my tangent theorem, I know that my tangent segments from a common point are congruent, right? So if they are congruent, then equal measure, right? So that's how we can set up our equation. 28 equals 3x plus 4. Now let's go ahead and solve. If I wanted to find the value of x, I'm going to subtract 4 first. So I have 3x equals 24 divided by 3, and x equals 8, right? All right, let's try another example. All right, here we go. Here's example 2. We have circle C again, and we have points B and D, and a common external tangent point of A. So the length, this is not an exact rendering of the circle. So A to B is 2x plus 7, and A to D is 5x minus 8. If they're congruent, then they're equal, so I know that 2x plus 7 equals 5x minus 8. So we'll move our 8 to the other side by adding. 2x plus 15 equals 5x. Subtract our 2x. 15 equals 3x, and then we'll divide, and x equals 5. All right, very nice. So that's your tangent theorem. If you have two tangents to an external point, your tangents are congruent. All right, so the other one is what we talked about earlier is that your tangent creates a right angle with your radius. So let's look at some problems when we see this. So this is called your tangent line to circle, which basically just tells us what we just said. If I have circle Q, right, and I have a tangent line anywhere on my circle, doesn't just have to be right here, and I draw a radius to meet that tangent point, then the angle formed with the radius and the tangent line is a right angle. So if a radius is drawn to a tangent, then it's 90 degrees, okay? So let's try some problems with this. And these get a little bit crazy, okay? So just hang in there with me, because if you think about a right angle, we're going to see some triangles here. We're going to be using that special theorem that we talk about all the time, right? The Pythagorean theorem. So here's our example 1. If I have a circle Q, another Q, and I have a point S, point of tangency is S, and I have this external point T. So here's my tangent point S, point of tangency, so I know that it creates a right angle, right? I have a radius and a radius. Remember, a radius is the same all the way around the circle. And this is 18 and 24. And I want to find out what the radius is. Think about what you're seeing here. You see a right triangle, right? So if I pull this right triangle out, my A value is R, my B value is 24, and my C value is this whole measure, R plus 18, okay? So it's gonna get a little bit hairy here, but that's okay. So let's plug it in. We have A squared plus B squared equals C squared. That's my Pythagorean theorem. I'm gonna plug in R for A. I'm gonna plug in 24 for B. And I'm gonna plug in R plus 18 for C. So let's work this out. R squared plus, all right, R squared plus 24 squared is 576 equals, this is R plus 18 times R plus 18. So bringing you back to 9th grade, you got a FOIL, right? First, outside, inside, last. So we have R squared plus 576 equals R times R, which is R squared, R times 18, which is 18R, 18 times R, 18R again, and then 18 times 18, which is 324. All right, don't worry, we're gonna work this out a little bit, okay? So we're gonna combine our like terms first. And you can skip some of these steps if you know them already. Plus 36R plus 324. Let's get our R squares together. So I'm going to subtract here and subtract here. Cancels on this side. Look at that. It cancels on this side too. That is nice. So I have 576 equals 36R plus 324. Subtract 324. We have 36R equals 576 minus 324, which is 252. And now divide 36. So 252 divided by 36 is 7. So our radius is 7 here. All right, many of your examples are going to be just like that. Go ahead and go to your discussion board and fill in that question that's being asked there, and that'll be your assignment for today.